let's see another graph problem from LeetCode. This is a medium level problem. It's a number of connected components in an undirected graph. So this is undirected graph where there is an age from 0 to 1 or 1 to 0, and also 1 to 2 and 2 to 1 and 3 to 4, 4 to 3. So this is undirected graph, and we need to return like what is the count of this connected graph. So if you see this example, there is one connected graph, this is another one connected graph, and in this case it should there should be just one connected graph here, output 1, because this is connected with like this. So that's we need to return. Since we have already done other graph problems, so it will be very easy. So it's even though it's a medium, but it seems easy because we have already done other graph problems. So here we just need to traverse from one vertex, and then again start with other vertex, and we'll do the DFS. Like there will be the vertex count given there, and like it's given we have a graph of n nodes, so n is given, so we'll start with n, and like in a n, if there is a 0, we'll start with 0, and it will go through all the connected components to the DFS. And so we also keep marking as visited, so we'll come here and mark it visited, come here, mark it visited, come here, mark it visited, and we check in a loop. We can check that, okay, if it is not visited, then count 1. So we'll start with 1 and start with this 0, and we'll say that, okay, it's not visited, then count 1, and we'll run the DFS. So DFS will end here and all will marked visited, and then we can get another, in a loop we get another vertex, and we'll check that, okay, if maybe you may get 1, but that's already visited, then we'll not increment the count. 2 is already visited, not increment the count. If you see the 3, and then in that case we increment the count because it's not visited, and then again run the DFS. So that's a very easy problem. So but when I say the easy problem, then you have to go and see this graph problems here. Like if you go to this LeetCode and you can search a graph, then you can see clone graph, and there is a course schedule. Okay, yeah, so especially you can just see this one, graph valid tree. So if you just see graph valid tree, this problem, and then graph valid tree, and then come back, and it will be very easy to understand. So I think the 2 video for this, just I recommend, like this one, course schedule. First see the course schedule, and then come back to this one, graph valid tree. So after these 2 videos, this problem is nothing, it's very easy. So I'm going to copy the code from the graph valid tree from this video. So same code, and I'll modify that code. And this video, graph valid tree, again depends on this one, course schedule. That's also a graph problem. So check that video and then come back here. So for now, this is the code last time I showed you about this graph valid tree. I'm just going to copy this code. I'll modify a little bit here, and then it's going to work. And then from here, I do not check this because this is the condition for the valid tree. So let's start with here. Put it here, and then I'll explain that again. Let me complete this, and then last this one. Okay, so we have the 2 variables, not visited and visited, and then this is the undirected graph. So we need to create a data structure. That's I have already mentioned in other videos how to do that, so you can see that video and then come back here. This loop is responsible for creating this graph data structure, where you can see this is the input, and in this input this is a one row, this is another row, and this is a third row, and we iterate through. This for loop is responsible for iterating through each row, and each row we know there are two values, 0 and 1, 1 and 2, 3, 4. So each row I'm getting the v1 and v2, and what I'm doing here for 0 key in a map, I put this 0 as a key, and for 0 1 is the value, and for 1 key again 0 will be value. So that's I'm maintaining here in this graph data structure. So if you see here, I'm just checking in a graph, that is graph is nothing but map. So I'm checking in a map if the key exists. So first time key will not exist. So if it does not exist, then I'll create a new array, and a new array I put v2. So for this 0 I'll put this 1 as a value. So this thing I have spent a lot of time in previous videos. You can, and this is a similar code, so I'm not going to explain a lot, but here we created the graph data structure, and then we do not need this anything here, this code. So since till here we created the graph data structure, and then we are going to run the DFS. I'll make one count variable, count is 0, and I will say this one for I is equal to 0 and I less than n I plus plus. Okay, and we'll say that a status I equal to not visited, then we'll call this function. So the n is a number of vertex, so we'll get the 0, 1 and 2. So there's a iteration, and we'll start DFS search from the 0. So we'll check first that 0 is not equal to like not visited, because first time we created a status array, and in this array this is size of n vertices. So this is status array, everything is like the 0, and the 0 is not visited. So not visited, I have put the not visited 0. So you can compare with directory status I equal to 0 or not visited, but I just put the name here so it will be easy to understand. So status I not visited, then we can call this function, and in this case we can increment the count. So count plus plus and return the count. So it's a loop here, and then we started with 0, and then we're saying if it is not visited, then count plus plus, and then do the DFS. So for this I'm just going to rename DFS, and here I'm passing the status parent. We do not need to pass. Yeah, so I'll remove this, and I'll rename this to the DFS. And when I go to the first node, I'll mark it visited, and then that this node is visited. And for this I'm trying to get the child, so graph B, and it will get all the childs will get here, and I'll check that if the child is visited or not. So for the 0, 1 is not visited. So if it is not visited, then in that case we can so I can check like this. If it is not visited, then I can call our DFS function here, DFS, and where you can pass graph, we can pass status, and we can pass v1, and we do not need this thing. Yeah, so that's all the logic, and we do not need. Yeah, so this very small logic here, we just put bool, we do not need. Yeah, so we start with the 0, and the 0 will mark it visited, and then for the 0 we'll get children or neighbors, so that is the 1, and we'll check that okay, status we are not visited, then I run again DFS v1. So with the v1 again we run the DFS, and again we'll come here, and 1 will marked as a visited, and then for 1 again I get the 2, that's 1 neighbor is 2, so that's the 2 will come here, and we'll check that 2 is not visited, and then it will run the DFS again, and for the 2 it will get the child again 1, but 1 is already visited, it will not go there. So this is done, and then it will come back and we'll get the first time that's count was 1, so that's good. And then again this iteration will go through all the vertices. So first we started with the 0, so we are done with that. Then it will get 1 and 2, so 1 is already visited, so it will not go to this condition. It is checking that status not visited, then only come here, but since it's already visited, it will not go here. Then it will come to 3, and the 3 is not visited, is true, then count plus plus, and then again run the DFS, and this will mark true, this will mark true, and come back here, so output will be 2. So this is the small logic for this. So let's run this. Undefined v. Okay, so here we need to pass I is the vertex. Accept it, submit this. Okay, that's good. I want to make this is a little bit shorter here, so this code, this one, like this whole line, I have already explained this thing in a previous video, you can go and check this out, but this whole line we can replace with just like this 2 line. And we do not need this thing. You can utilize that also in the previous videos. So what I'm doing, the graph v1, first time it's a graph v1, and this graph v1 for 0, in the first time, the 0 will be the key, so the 0 will get searched in this map and it will not available, so it will return empty array, because the map data structure is map key and the value is the array, so empty array. So in an empty array we append the v2, so that's the v2, that's the value for the 0, this 1 is the value, so we'll put that here. And again for this graph v2 also it's the same thing. For this key, first time it will not be available, this key, then for this key the graph v2 returns empty array, and in an empty array we put the v1 0. So in that way this graph data structure will be created. So if, let's say there is another component here in this case, so next time if the key already exists, then if the key already exists, then for this 0 key we already have the 1, so it will return the array of that's 1 in the array value, and we can append the other value. So this is a smaller version of this. Let me run this first and submit. So that's also good. So the Java solutions also so from the previous video, so you can modify the code and you can do this. So that's all for now. Thank you.